Have you ever wondered why airplanes don't rust easily or why jewelry doesn't bend or break? The answer lies in one incredible concept: alloys. In this video, we'll observe how various metals combine to create alloys and talk about the importance of it in our daily lives. So, what exactly is an alloy? An alloy is a mixture of two or more elements where the main element is a metal. By combining metals, or even metals and nonmetals, scientists can create materials with improved properties. Example: pure iron is strong, but it rusts easily. Add a little carbon and you get steel, much stronger and resistant to corrosion. Most alloys are made by melting and reacting metals together, which usually results in the metal atoms forming metallic bonds with each other and mixing fully into the lattice structure. A new metallic lattice structure with varying properties that are harder, sometimes lighter, and sometimes more flexible, can be created by distributing these linkages freely and without following predetermined proportions. Now, what are the differences between alloys and pure metals? Since there are still insufficient electrons to complete the valence shell of any atom in a pure metal, electrons can flow freely between atoms, making metals excellent conductors of heat and electricity. Furthermore, the lack of permanent bonding allows the atoms to move past one another, making the metals flexible and malleable. This gives them the ability to change their shape and is relatively easy to melt and bend, but difficult to vaporize. Atoms in metals actually slide over one another when they change shape, like so. An analogy to this is attempting to move a carpet by putting a rock in it. This process occurs gradually, rather than all at once. This is how it takes place in a metal. One atom at a time, you can observe the slip moving effortlessly where the lattice is dislocated. The softness or lack of hardness of most pure metals is caused by the easy mobility of atoms inside the crystal lattice. Now, this simple dislocation movement is stopped when a larger or smaller atom is added to the lattice. Observe how the larger atom causes the dislocation to stabilize, making it harder to bend the alloy unless you apply a greater force to it. To finish off, let's take a look at some well-known examples of alloys and its uses in daily life. Duralumin, consisting of 93% aluminium, 3% copper and magnesium, as well as 1% manganese, is used to make body or aeroplanes, electric cables and racing bicycles due to its low density and resistance to rust. Bronze, which is made up of 90% copper and 10% tin, is used for medals, monuments and trophies due to its shiny property. Another alloy, which is mainly copper, is brass, consisting of 70% copper and 30% zinc, is used for the production of musical instruments, doorknobs and keys. Steel, also known as carbon steel, is used for railway tracks, body of cars and structure of buildings. Stainless steel, however, has 73% iron, 18% chromium, 8% nickel, and 1% carbon is used for cutlery and sinks as well as surgical instruments due to its resistance to corrosion. Pewter, comprising 95% tin, 3.5% antimony, and 1.5% copper, is mainly used to make decorative ornaments, souvenirs, and trophies.